Alright, welcome once again. So, last module we have seen inverting amplifier, this module we will see non-inverting amplifier, right. So, let us quickly see the screen, and what we see here a circuit for non-inverting amplifier. We have already seen again in this in theory class, theory classes. Just quickly let us recall. So, non-inverting amplifier closed loop configuration, external components R1 and R2, right. R1 and R2 we have also used in the inverting amplifier, right. So, this is a non-inverting amplifier, that means the signal will go to the non-inverting terminal, and whatever signal we are giving here, we have to check the output. The output voltage, output is feedback to the inverting amplifier, this is here. Input signal is applied for non-inverting amplifier, which is this one. Non-inverting amplifier configuration using ideal op amp. So, again the same thing, you see you do not have to really worry when somebody asks you that what are the required condition to apply virtual short circuit for op amp circuit or virtual short for op amp circuit in case of inverting amplifier or in case of non-inverting amplifier. It's kind of same, you see negative feedback configuration, infinite open loop gain is kind of same, right. Op amp characteristics, once you know, it becomes easy. Now, closed loop gain, what is closed loop gain? Closed loop gain formula we have seen is nothing but 1 plus R2 by R1. So, if you see here this particular circuit, this circuit, right, this circuit, what we see that the input is given to terminal non-inverting terminal, right, and if you calculate the current, right, then V1 by R1 is flowing here, V1 by R1 towards this side, V1 is going towards this, the differential voltage is 0 volt, right. We have grounded this terminal, and now we are applying voltage at the non-inverting amplifier. For the output that we have seen in the theory class, that will be nothing but VO equals to 1 plus RF, right, by R1 into V in. This is what we have seen in the class, right. The same thing is here, it is same thing. So, let me just move this thing out, so you can just concentrate here. Let us remove this. Okay, what you see here, concentrate on only this, alright. It is written VO equals to V in into 1 plus RF by R1. RF here is what? R2, that is why we are saying 1 plus R2 by R1, very easy, extremely easy. Infinite input impedance, same thing we are saying 100 times. So, it's very difficult to forget. If somebody asks you, it is very difficult to forget this thing, right. Infinite differential gain, infinite input impedance, 0 output impedance, closed loop gain depends entirely on external passive components, same thing we have repeated in inverting amplifier, same is there for non-inverting amplifier. And finally, closed loop amplifier trades gain, that means that for accuracy finite but accurate closed loop gain, that means we can change the gain if we apply closed loop, right, we have a control over the closed loop gain when we apply the feedback to the amplifier. Now, the one thing that we have to understand clearly is that in non-inverting amplifier the case was that if I say this is, let me write it down. So, if this is input, this is output, alright, then in case of inverting amplifier, I am writing just minus as inverting amplifier, signal if I apply here, output would be opposite, right, 180 degree opposite. In case of non-inverting amplifier, I am just showing by plus symbol, right. This is not our actual symbol, I am just for ease of communication I am showing with a particular symbol which is plus, okay. So, non-inverting amplifier, when you apply input signal, the output signal will be in phase, you see this is 180 degree out of phase, this is 0 degree, this is also 0 degree, right. Or like yesterday we have seen or in few other classes that 360 degree is the input and 360 degree is the output. So, it is same thing, phase is not changed, phase remains same, there is amplification in non-inverting amplifier. Inverting amplifier, the amplification is there, but there is a phase change of 180 degree. That is the main difference between non-inverting and inverting amplifier from ease point of view to understand it quickly, alright. But now we have to see this thing happening with the circuit, right. So, how can we perform an experiment and validate that whatever we are claiming here, that means that what we are claiming here in non-inverting amplifier, that when we apply as input signal, which is this one input, your output would be in phase with input, your output would be in phase with input. So, we have to validate it, right. So, validating this particular thing we have to perform an experiment. Experiment with what? Experiment operation amplifier, experiment with resistors, experiment with your with your signals, and let us see what exactly the experiment consists of. This is the process. So, again you understand this table. If you see the table looks exactly similar to your inverting amplifier, right. Inverting amplifier, what we are looking at, V in, V out by V in. Same thing we are doing at non-inverting amplifier, only here is the formula is changed. Formula for output voltage is 1 plus R2 by R1 into V in. Formula for inverting amplifier was V out equals to minus R2 by R1 into V in. Only thing is the change in formula, right. So, first, what is the first thing, we have to connect the circuit as shown in figure. This is the figure, this is the figure, alright. We have to connect the circuit. Now, generally when you show this, right, that does not mean that we are not applying the bias voltage. Even it is not shown, it is assumed that there is a bias voltage applied across the terminal, plus VCC minus VEE. This is already applied, plus minus 15 we have applied, alright. So, even some even you see the circuit where there is, this is not given, that does not mean that the VCC and VE is not given, because without bias voltage you cannot operate the amplifier, alright. Then same thing again, see, apply 1 volts peak to peak sine wave 1 kilohertz to V in. So, we are applying the same voltage. What is the voltage peak to peak? 1 volts. Peak to peak is this peak to this peak, peak to peak 1 volts, 1 kilohertz is the frequency, right. Observe the output V out and note down peak to peak voltage in the table below. So easy. So, apply V in, measure the output, note down the output, right. Repeat the experiments for higher and lower amplitudes and note down the observation. So, let us see how we can perform this particular experiment, alright. So, again I will request Suman Chatterjee to help us with the experiment. So, if you see the breadboard, then the breadboard we have already connected the non-inverting amplifier. We have not given the input signal to the non-inverting amplifier yet, but the circuit, that is where I am pointing my finger, right, this particular circuit or this one here, right, this is the non-inverting amplifier. Now, do not get confused, it is not really different, it is same thing that we have seen on the screen, exactly same thing, right. What we have to do, we have to apply the bias voltage plus minus 15, and we have to connect our function generator, that is signal generated from the function generator, to the non-inverting input of this operational amplifier. The output of the operational amplifier will connect to the oscilloscope. So, first he will apply connect the bias voltage. So, if you see DC in this one, DC supply please, yes, switch it on, plus minus 15. So, he will first connect plus minus 15 to the circuit. This is the first thing that you have to do, right. So, plus 15, and now it is already on. So, we have to first switch it off, alright. Now, you apply plus minus 15, it is already there, actually you have to switch off the this one also, but I am not doing that, that is fine. Alright, see there is no voltage coming from the DC regulator, right, to the circuit, right. Even you do not have to take this much of chance, alright. Be extremely safe when you perform any experiment, alright. So, we now have connected what? We have connected plus 15 minus 15 to the non-inverting operational amplifier, that means 7 and 4, pin number 4 and pin number 7 are connected with minus 15 and plus 15 respectively, alright. Now, we will apply input signal. So, this is your input signal. Before that we have to start the operation amplifier. So, we can now start, we can apply the power, yes, DC voltage, excellent. So, DC voltage again you know, right, here it is plus 15 minus 15 in this 3, red, black, green, alright. Now, we will apply the input signal from the frequency generator. So, what is the frequency generator input signal? Can we focus on frequency generator please? Right. So, I have shown you, right, you can change the input signal very easily. One volt, if you see high, it is 1 volt is applied, right. What is the frequency? 1 kilohertz is the frequency, voltage is 1 volt, right, voltage is 1 volt and frequency is 1 kilohertz. This is the input signal. Now, he is going to connect this particular circuit, right, and he is applying input signal to the operation amplifier. Again you see DC voltage, we can switch it off when we require, then we can switch it on, alright. So, we can switch it off again, DC voltage please, yeah, when we require we can switch it on, alright. Can you please connect it? So, now he is connecting the signal to the non-inverting amplifier, another terminal to ground, that is how signal is given, alright, another terminal to ground. Okay. So, if you see the breadboard, let us see little bit of breadboard. Okay. You see, so this black one is connected to a breadboard, right, with a to a ground terminal. These are all ground, alright, and this side of the breadboard we have kept plus VCC ground, plus VCC ground, always remember this thing, alright. This is how we are done. Now we are applying signal through this one, right, to the non-inverting terminal of the operation amplifier. So, this wire is connected to the circuit, you see here this wire is connected to the non-inverting amplifier, non-inverting amplifier and input of the non-inverting terminal, this op amp non-inverting terminal input is here, alright. So, understand from here frequency generator input goes to the non-inverting terminal. Now, what we have to do? We have to check the output. So, let us see the output. If we connect the output to the oscilloscope, again see this oscilloscope here, alright. So, these are the probes for the oscilloscope, you see the probes, right, in my hand, these are probes, right. Now, we have to connect this probe to the output of the operation amplifier, so that we can understand what is the signal. So, he will connect it to the output, and another terminal to ground, excellent, right. So, now what we are expecting when we connect this thing, what we will be able to see, we will try to see what is the output signal when we are applying a input signal of 1 volt 1 kilohertz. Okay. So, now the circuit is connected, right, we have to look here. Okay. So, you can see that when power was not on, you were not able to see, right. So, do not forget to apply the bias voltage, without bias voltage you cannot see the signal. Now, there is some problem with the circuit, right, is not it, because we cannot see exact replication of the signal. So, let us find out what is the problem, alright, let us find out what is the problem, and then we will be I will tell you what is the problem, so that you also understand. Then when actually you are fabricating or actually you are testing the circuit, there can be this kind of problem where you suddenly see that the signal is not replicating, and that is absolutely fine, that is not a problem in that. So, but the main thing is, can you rectify this problem, that is the main thing. So, we will try to rectify it and we will continue. So, I told you, right, there was some mistake, right, and that is perfectly fine. The point is, can we identify what was the error in the circuit. Now, actually there was no error in the circuit. What we found is that you see here the display, it is showing a sine wave right here, but there are two channels, you see, channel 1 and channel 2. So, channel 2 is configured in square wave, channel 1 is configured in sine wave. What we did is, last time we have applied square wave to the circuit. So, when we apply square wave to the circuit, what we are assuming? We are assuming at the oscilloscope square wave signal, you can see, right, that is absolutely fine. So, what if you apply input as sine, you will get a sine, you apply square, you will get a square. But the point is, what was the input signal? Input signal was 1 volts peak to peak 1 kilohertz. What is the output signal? Output signal is, we have to see here in the oscilloscope. Can we please focus oscilloscope, so I can show them what is the output signal. Can you please point it out here? So, if you see, it is around 11 volts peak to peak when we apply, or 11.8 to 12 volts peak to peak, right, blue one, and the input voltage is 1.04 volt. That means that it is amplified, the signal is amplified. But one thing that we have to keep in mind is, this is a non-inverting amplifier. So, you can see the phase is 0 degree phase shift, right. If you see here, then you see go down, no phase shift, right. So, phase shift is 0 degree, but in case of inverting phase shift was 180 degree. Now let us see, instead of applying square wave, if we apply sine wave. So if you again focus on the frequency generator, now we have configured our channel 1. There are two channels. We have already seen in the previous modules what is this function generator and how many channels are there, right. So now channel 2 is square wave. Let us change it to channel 1 please. So see, by pressing a button we convert to channel 1. What is channel 1? Sine wave, right. What is channel 1? Sine wave. So now we are applying sine wave to the circuit. When we are applying sine wave to the circuit, we have to connect the probe, that is for the sine wave, to the circuit, isn't it? Otherwise we cannot get the signal. So what we have to do? We have to, so we are taking out the probe, alright. You need to be gentle, right. When you take out the probe, when you insert the probe, it's a easy way of doing it, right. Use any equipment, be extremely gentle, okay. Do not take out your frustrations on equipment, guys. It is very easy, operation is extremely simple, alright. So when you connect your frequency generator, now we are applying sine wave, right. So we have to now see the oscilloscope. What we see is the amplification of the signal, sine wave 1 volt, whatever amplification we get, around 12 volts, 1.04 is the input, 12 volts is the output. Phase shift 0 degree, very easy, right. If you say inverting, phase shift 180, non-inverting, phase shift 0 degree, both are amplifiers. So there will be amplification. Non-inverting terminal, the formula is 1 plus R, non-inverting amplifier formula is 1 plus Rf by R1 or Rin into V in. Inverting amplifier formula is V out equals to minus Rf by Rin into V in. So using that formula, if you calculate theoretical calculation of amplification or gain and actual gain, you will see the difference, little bit of difference, not significantly. So once we know this, we can go back to our table on the screen and we can note down the value. What is the value? V in. What is V in? 1.04. What is output? 12 volts, right. What is V out by V in? 12 divided by 1.04, that is your gain, so easy. Theoretical gain R2 by R1 into 1 plus R2 by R1. So what is that? 1 plus R2 by R1, 1 plus 10 by 1, right. 1 plus 10 by 1 is 1 plus 10 or 11. So let me write it on clearly, so you can see here, right. 1 plus 10 by 1, which is equals to 1 plus 10, which is equals to 11, correct, 11 volts or 11 times amplification factor, into V in, into whatever V in is 1.04. So when we multiply 11 by 1.04, the gain is 11, directly gain is 11, right. But what is output voltage? Output voltage would be different. So we can see there is a little bit different between the actual experimental value and the theoretical value, alright. Now what is another thing that we have written here in the experiment? The second part. So we have, what we have done? We have done this, right. We have also calculated, observe this one, 3 things are done. What is 4th thing? Apply higher voltage, right, higher amplitudes. Let us see, when we apply higher amplitudes what happens. So if we again go back to the from frequency generator, function generator, yes. So if you can see function generator please, yes. Now let us apply high voltage, right. So instead of 1 volts, what he is doing now, he is applying another voltage. Let us apply 2 volts, right. Let us apply 2 volts. Now what is the amplification? Amplification is about, gain is about 1 plus R2 by R1, about 11. So 2 into 11 will be 22, right, 2 into 11 will be 22. Now what is the input bias voltage? Bias voltage is plus minus 15 volts. So output, how output will be look like? Output will be clipped. Can we see the output now? So this input signal is applied to the circuit, from the circuit it goes to the output. So if you see the output voltage, you will see a clip. You see the clip? The clipping is because the output is more than the bias voltage, That is what I have told you earlier, right, as an example. One single op amp cannot amplify infinitely, or it can amplify infinitely, but it has to depend on the bias voltage. So, bias voltage is extremely important when we are talking about the amplifier, alright, without that it is not useful. So, what we have found? We have found that if we use inverting amplifier we see 180 degree phase shift, if we use non-inverting amplifier we see 0 degree phase shift. In both the cases when we amplify, when we apply the input signal and we have a gain which gives our output signal more than the input bias voltages, that is plus minus 15, we see a clipping, right. But what if we decrease it in decreasing condition? So, if we can quickly decrease it, decrease the voltage here in the input. So, decreasing the voltage will give us, let us say we are applying about 0.5 volts peak to peak, 0.5 volts peak to peak will give us output which we can see here in the oscilloscope, right. So, it has amplified about 11 times. So, 11 times 0.5 would be around 5.5, right, around 5.5. So, that is what we can see, about 6 point something volts actual. So, so why there is a change? You see, so we have calculated about 5.5 volts should be the output, but when we see in the oscilloscope we find that it is around 6 volts, right. So, that is because the resistor value that we are using it, that is your 10 kilo ohm and 1 kilo ohm, it may not be 10 kilo ohm or it may not be 1 kilo ohm, even a change of few ohms will change the gain, right. So, it is extremely important when we use the circuit, you should measure what is the resistance of the resistor and then you understand theoretical and experimental calculations. So, anyway, the point is, in non-inverting amplifier there is no phase shift, inverting amplifier there was a phase shift. Take care of using the resistors, right, its value should be accurate, then only you can compare theory with practical, alright. So, this is the end of this particular module. Like I said, it is absolutely okay when you are trying experiment on the breadboard and you are trying different circuits, right, and you are not able to get the answer what you are expecting, that is absolutely okay. So, what we have to rectify, we have to understand what was the problem. So, here if you have seen in this particular experiment, the problem, there was no problem with the circuit, it was problem with the input signal, right. Input signal given to the circuit was square wave and we were assuming, or we were under the impression that input is sine wave and why the output is square wave. So, we have to understand, if the input is something, we cannot expect output which is different than what is input signal, we can only amplify it, right. But we can also use clipping, its clipping is there when your amplification of the gain or of the amplification of the voltage is more than the bias voltages. So, keeping in this mind, I will see you in the next module, and next module will be on understanding the input and output ranges, or the range of the operation amplifier. See you.